Hello everyone, this is a video lecture for pre-calculus. We're doing 5.3 reference angles. And put a dot there. Anyways, so reference angles are basically acute angles with the x-axis, and we're going to use them to get better answers and unit circle and all this other stuff, okay? You've memorized your unit circle by now, haven't you? Haven't you? Anyways, reference angle. I'm just going to give you more of like a official definition, so I don't have to do it again. Reference angle is an acute angle with the x-axis that is coterminal, blah, 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 coterminal, all that kind of stuff. Okay. I don't know if I would say coterminal. I'm going to put it in quotes. It acts like a coterminal thing. If you're confused, so am I, because I don't really do this very often. I don't think like this, but I'll show you whenever it comes up, I guess. Anyways, but you definitely need your unit circle, and I would recommend having it next to you while we're doing it, or if you've already memorized it, all the better. 5, 3, 1. It says that I got -9, 12 is an XY point, okay? And they say, first off, find the radius. Okay, so what's going on here is we have a point at -9, positive 12. It's out here. And they say, what's that radius? What's that distance to get out there? Well, it's Pythagorean theorem. And so I'm going to do the -9 squared plus the 12 squared is equal to, and it's 15. I'm just going to go ahead and give the answer. It's 15. You put it all into the calculator, you get a 15. Okay, awesome. So there's your first answer. Now, they say, well, go ahead and find the sine of theta, the cosine of theta, and the tangent of theta, just like we did last section. Instead of thinking of it like opposite over adjacent, and I'm sorry, opposite over hypotenuse and stuff like that, it's now going to be y over r. And it's the same formula, but now I'm using these other ones. So y over r, x over r, y over x, same thing. So don't let it confuse you. It's the same thing. 12 over 15. In this particular case, it's a 4 over 5 whenever you reduce it down. We got -9 over 15. -3 over 5. 12 over -9. So -4 over 3. And there you go. That was it. Cool. Hey, go ahead and find the cosecant, secant, and cotangent. Well, you just flip them and blah, blah, blah. Can you get, like, are you getting these vibes from me right now that I'm bored? That I'm bored of doing that? I want something new and interesting, you know? I mean, yeah, sine, cosine, and tangent, flip it, blah, blah, blah. I mean, it's cool to find these guys. This is good stuff here, but it's the same formula we just did. And then they say flip it, which is the same thing we just did. So there's nothing new here. Hey, did you do Pythagorean before? Yes, it's the same thing. I'm hoping that you're seeing that, and in a good way. I mean, yay, we get to do the same thing, but in a way it's also easier that way. So don't overthink it. If this seems like, oh, I don't know what they're talking about, yeah, you do. You've already did it. If you've gotten this far, then you've already been through all this stuff. Find the radius, Pythagorean theorem, etc. Now, this one doesn't reduce down. It's just square root 58, and that's kind of rough, but it works. I mean, that's fine. Now it says, hey, go ahead and find the sine. You're like, woohoo, yay, I love doing this. So we got y over r. I'm trying to be enthusiastic here, but, you know, sometimes it's tough. So we got 3 over the square root of 58. Yay! X over r. I didn't even do any of this in my notes. I just said, nah, it's the same. So I'm trying here. I'm trying. And then my tangent is y over x. And so I got -3 over -7, and there you go. Well, all of these are totally wrong. Totally wrong. And so what we need to do instead is to rationalize denominators and simplify and all that kind of stuff. So this is frankly really annoying to me, but it's okay. We could do this. You take the 3, you take that square root, you pop it up into the top, but then you leave the number behind. There you go. Same thing with this guy. You have the square root of 58. Awesome. And then you leave the number behind. And this one, just 2 negatives will make a positive, so 3/7 and you're done. That's all. Okay, and then, hey, same thing. It's saying now that we need to find the cosecant, and then the secant, and then the cotangent. Oh, so hard. So no, it's not. It's not. But I do want to make a small mention here. Okay, I do want to make a small mention. If you want to take this one and flip it, that'll be okay. You're just going to cause yourself a world of problems. It works, but then you'd have to simplify again, and it's so messy and long. Why don't you flip this one instead? And I want you to do that on your paper. I want you to flip this answer and see when you come up with this answer. How many steps does it take to undo what you've done? Rather than just taking what you had and flipping it, and there you go. Same thing with this guy. Flip this one instead. So still a negative 58 over the 7. Again, you can put a negative up top, bottom side, doesn't matter. It's all the same. And then this guy's super easy to flip. There you go. So you're still flipping them, but I recommend using this one right here, okay? So see, this is new material now, finally. I don't know. There you go. There's nothing else to talk about. There you go. That was fun. Next problem. We'll get to new stuff here in just a few minutes, but on your homework, you should assume that you'll be really bored of doing the same thing so many times, because I was. Okay, it says cotangent of pi. Find the answer. So you go to your calculator. Kinda. You can't put cotangent in there, but you can put tangent in there, so you can do 1 over tangent. And yeah, your calculator basically just says it's 0. There you go. It's not hard. It's not hard. Now, does that work? Hold on. Give me a second here right quick. I don't think it's 0. I think I wrote something down wrong here. Hold on. Burp, burp. Give me a second. 1 divided by the tangent of pi. And am I in radian mode? No. Give me a second. Error. Okay, good. Let's talk about this for a second, okay? I don't know what I was thinking here. This is all kind of weird. Let's just back up. Back up. I want to put this into the calculator, and I get an error, okay? Awesome. What does that mean? Well, it means that I have this bottom part here is like not working. Something's going a problem, essentially. So is it the tangent part? Is the 1 over the tangent part? I don't know. So instead, I'm now going to do tangent of pi, and I'm going to see what it says. Just plain old tangent pi, nothing else, okay? Let's just do that. So tangent of pi and 0. Oh, whoa. Yep, I'm just going to verify here, okay? Tangent of pi is a 0, yes. So if tangent of pi is a 0, and I did 1 over tangent pi, and it said an error, why is that? What's going on here? What is that? Well, that is undefined, isn't it? Divide by 0, undefined. So what's my answer to this is actually, yeah, I don't know what I was thinking on my paper here. My paper's all messed up. Give me a second here. Okay. It's undefined. The answer is undefined. And so you would have to click like, I don't know, it doesn't work. And there you go. Let's talk about this for a second a little bit more, okay? I know, I goofed up. My notes were wrong, and so now, no video editing here, okay, guys? And I was talking about how easy this was. It is. It is. So tangent of theta is equal to y over x. Okay? Awesome. Well, this is also equal to rise over run. Where have I heard that before? Oh, yeah. It's slope, like the m in the mx plus b. Oh, okay. Cool, cool. So I want to know what this tangent pi is. And so we got 0, pi over 2, and pi. So I'm facing this way. I'm looking like this. And I'm going to ask you, looking at this bold arrow thingy, what is my slope for this? What's my slope? Well, it's a flat line. So it's 0. My tangent's equal to slope. My tangent is equal to 0. Okay? Cool. Well, they're asking for the cotangent. Cotangent's 1 over tangent. I just discovered that my tangent's 0. 1 over 0 is undefined. Okay? So that's kind of like the theory here. Moving on. So 5. I know. I mean, it's not that bad in the end. Okay, this one's actually pretty cool. We're doing the quadrants and stuff, and then they'll be useful later. Okay, so this is a shorter answer for what we're going to do later. My cosine of theta is greater than 0. Cosecant of theta is greater than 0. And they say, what quadrant is this in? 1, 2, or 3, or 4. It's multiple choice. Your cosine is an x value, essentially, whenever you're talking about unit circle and everything like that. So my x value is greater than 0. Cosecant is basically a y value, because it's basically equal to a sine. You know, it's like 1 over the sine, which is equal to a y value. And so you're saying that your y value is greater than 0. Your x value is greater than 0, your y value is greater than 0. They're both positive. It's right here. That's quadrant 1. There you go. So there's your answers. 1. Quadrant 1. Okay. 5, 3, 25. So now we're going to use it to our advantage a bit. I got sine of theta is equal to 12 over 13. And they say, hey, this thing is in quadrant 2. Ah, thank you for telling me. Find the cosine of theta. And find the tangent of theta. Okay. Oh, that just didn't look very good there. There we go. Well, we're definitely in quadrant 2, so go ahead and draw that at least, okay? When we're talking then about quadrant 2, what I'd rather see, no, I'll use this is fine, is a triangle. This is the opposite, 12. This is my hypotenuse, 13. So I need to find my adjacent. Now, be careful when you're doing this. It's still Pythagorean theorem, 13 squared minus the 12 squared. When you do that in the calculator, I got a 5. But it's not 5. It's negative 5. Okay? And the reason why it's negative 5 is, well, look at the picture. Isn't that going to be a negative? Quadrant 2. Keep that in mind as you're going through this, okay? So, okay, here we go. Cosine is going to be x or adjacent over your hypotenuse. So negative 5 over the 13. There you go, done. Tangent is opposite over adjacent. 12 over the negative 5. You're done. Whew. And on your homework, they still want you to do more. So go and take these and flip them and blah, blah, blah. You're going to flip this guy as well, by the way, for your cosecant. I am so sorry, guys. I am so sorry you have to do that every single time. Because, honestly, I just gave up. It's just so much. I've done it all before, okay? I did it whenever I was a student. So now I have to torture you and do it? No, I don't make those decisions. But it is something you still need to do. We're practicing together. Whew, it's okay. Just like do it in small jumps. Don't do it all at once, right? Okay. So I've got a tangent of theta is equal to this negative 1/5. And they say cosecant is less than 0. Again, when they say cosecant, they're basically saying sine. And so they're basically saying my y value. And so my y value is less than 0. But tangent is a negative. My slope is a negative. Negative slope is actually, it looks like this, right? There's your line. But it says that y is less than 0. So it's got to be below the x-axis. So the only quadrant that makes sense now is right here. So we're definitely in quadrant 4, okay? Now, I'm going to set up a triangle in quadrant 4 to make this work. And it's not going to be to scale. It's not perfect. I'm just making up a triangle here. So this is the opposite, -1, and my adjacent is a +5. But that makes sense, doesn't it? See, I went down. I'm going positive land. Totally fine. But this, again, be careful. You could have had this, but now that wouldn't have made sense. That would have been somewhere over here, and that's not quadrant 4 anymore. So that negative sign can go in the top or the bottom. Here, it made sense to have it up here instead of there. But you'll probably see me do another problem where I have to flip them, and that's totally fine. Okay, so we have a triangle. There's my theta. And I need to find the hypotenuse to keep going. So here we go. 5 squared plus -1 squared. Square root of 26. Which I don't think reduces. So that's square root 26. And now they say, find the sine, find the cosine, and all that other stuff. I don't think they need to find the tangent because, well, you already got it right there. So, looking at my problem here, I got opposite over the hypotenuse. And we need to rationalize it. So I take that square root and pop it into the top. You don't need the 1 in the front. It'll probably freak out saying, it's not simplified. So go ahead and get, oh, that's a 26. Go ahead and get rid of the 1. There you go. Okay, cosine is adjacent over the hypotenuse. So 5 over the square root of 26. Again, rewrite it, rationalizing the denominator, and there you go. Okay? You can see why I'm doing these quicker methods. Like you've been seeing this in the past sections where I say, hey, this is just what I do because it makes it faster. Every little bit to make these things faster helps because you're doing this so many times. So there we go. I'm looking here and oh, never mind. I was looking at the wrong problem. We're good. I'm looking like, why did I get all these weird answers? That was a previous problem. We're good. All right, now I had promised reference angles, and now we're finally doing it. But again, when I say reference angles, I mean unit circle. So here we go. Not really. Not in my math lab's case. No way. So reference angle. They want the reference angle for 151 degrees. Okay, now I already told you it's an acute angle with the x-axis that's coterminal, et cetera, et cetera. So 151 degrees is somewhere over here. And I made that because it's like that. That's my 151 degrees. So I'm looking for something right here, that small little acute angle with the x-axis. And how would I find that in this particular case? Well, I know that this is 180, and that's 151. So if I did the 180 minus the 151, I would get 29 degrees, and that's your answer. That's your reference angle. Notice 29, that's acute. That means it's less than 90 degrees. So that's good. Everything checks out. That's exactly what we wanted to do. Now, in this particular case, what I did was 180 minus my angle. Sometimes I'm going to do my angle minus 180. Sometimes I use a 360. And so I have kind of like a proto formula for you. That's a bit too big. Okay, there we go. This is a proto formula. To find the reference angle, depending on what quadrant you're in, you're going to use theta, as in you don't change anything. What's the reference angle for 30 degrees? It's 30 degrees. It's the same thing. The formula over here, though, is 180 minus your theta. That's what we just did a second ago. This here is theta minus 180. And here it's going to be 360 minus your theta. Okay, that's kind of like a formula. This is something you can put on the formula card for exams and all that kind of stuff. Of course, you can replace this with pies and 2 pies, all the same. All right, let's do another problem. So I got 5, 3, 39. It says find the reference angle for 288 degrees. All right, what quadrant's that in? That's about right here. And I know that because straight down is 270, okay? So I want this small angle here. Using the formula, I'm going to use that 360 minus the angle. So 360 minus the 288, and definitely calculator because I don't know that stuff, and it's 72 degrees. There you go. Cool. Keep cruising. 5, 3, 41. So it says find the reference angle for 6 pi over 5. Okay. So there's lots of other ways to see this, but I'm going to do my formula thing. 6 pi over 5 is somewhere over here. I know that because 5 pi over 5 would be right there. That's pi, right? So pi, 1 pi, 5 pi over 5. So it's a little bit more than that. But they're just wanting this small little angle right there. So I can go back to my little formula, and what it is, it's going to be theta minus pi, theta minus 180, essentially. I do not need to convert this into degrees to make this thing work, okay? This is much faster if you just know that the formulas are flexible. Flexible formulas. So this is a 1, so 6/5 minus 1 is 1/5. You got it. Radians. And there you go. Now, why are these reference angles so important to you? Well, because they're saying you're going to use unit circle, or if you've memorized quadrant 1, then you can still use the unit circle, but none of this is actually on the unit circle, and you're just doing the homework because they tell you to do it this way. 23 pi over 5, and they say, what's the reference angle? I don't even know, because this is so far out there. It's way big. Like 2 pi is a full revolution. What is this? Here, let me just find it. 23, here, hold on. 23 divided by 5 is 4.6 pi. So that's like, it's a couple revolutions too much, essentially, okay? So what I want to do is I'm going to take this, and I've got to, like, calm it down. It's just too much. It's like I'm going around and around and around and around. I need to, like, back it up to a single revolution. And again, we've already done this before. I'm going to take my 23 over 5 pi. I'm going to subtract 2 pi from it. So we're going to get a blank pi. And I'm just going to give you the answers here. It's 17 over 3. Was it 4.6, by the way? Oh, I wrote it down wrong. I wrote it down wrong. Just ignore me. I'm going to keep cruising, okay? It was actually a 3 down here, not a 5. Whatever. It'll be fine. So why did I write a 3? It's because my notes were wrong. Actually, I don't know what it's going to be now. So, hold on. So, yeah, 23 divided by 5, and then minus the 2 gives me 13 over 5. Okay. Is that within 2? No. So do it again. 13 over 5 pi minus the 2 pi again. So 13 divided by 5 minus the 2 is 3/5 pi. And that's definitely within the first revolution. But I need an acute angle. Now, let's see what this looks like. I need to take this pie, this part here, and cut it up into 5 pizza slices. So 1, 2, 3, 4, 5. There's 5 pizza slices. And I want 3 of the pizza slices for myself. So 1, 2, 3 pizza slices. So I'm somewhere over here in quadrant 2. Okay? To get the acute angle, I need this amount right there. And so there's a formula for being in quadrant 2. What do? it's going to be the 180 minus your theta, or in this case, pi minus theta. And so I'm going to do 1 pi minus 3/5 pi. And if you do the math here, it's 2/5 pi. So all of that was on the fly because apparently I messed up the original. But that is okay. We still got an answer, and that's what my math lab would have anyways. Okay. 5/361. I'm going to write it sideways just because I can. I got sine of 210 degrees is equal to blank. They say, go ahead and figure this thing out. Well, it's not exactly the whole picture. This is part B. Part A says, hey, go ahead and find the reference angle. Okay, I guess. That's fine. So 210 is about right here. And I need to find the little reference angle there. There's a formula for that. We're going to take the angle minus 180. And we got a 30. Yay! Now, they're saying that whatever we're going to get here is pretty much the same as saying sine of 30. So if you knew sine of 30, you just get the answer. But you have a unit circle, right? So, I know. Let's just keep going for just a second. It's going to be okay. So sine of 30. Oh, I know sine of 30. Yeah, that's going to be a 1/2. Totally wrong because it's not 1/2. The answer is -1/2. What? How did that work? Indeed, the sine of 30 is going to be 1/2 right here. So you have your y value is going to be 1/2. This is the square root 3/2, and this is a 1. All that kind of stuff, okay? Super awesome. But this is quadrant 1. We're in quadrant 3, where the y value is negative. And so you can't just keep the value that you got. That's why it's a kinda. It's actually equal to a -1/2. So the number is still there, but you have to make sure it's a positive or negative. If that was confusing to you, why can't you just plug this into the calculator, right? And it says it's -1/2. You're done. That's it. That's all you had to do. I'm serious. So I don't like using reference angles sometimes because what happens is that I get the answer, but it's not really the answer because I need to put a negative or a positive. Instead, if you just had the whole unit circle, you'd be done. Okay. It's just my personal preferences there. Sorry. Maybe I'm just agitated at this point. So find the tangent of this guy. I am so tempted just to go to the calculator. And there's so many good things to learn about the calculator in this way. But they want the reference angle, so here we go. First off, 780 is way too big, so I need to subtract 360. 780 minus 360 is 420. So then I do it again, 420 minus 360. Again, 420 minus 360 is 60. And that right there is an acute angle, so that is your reference angle without having to do any other formulas. Sometimes we have to go and do another formula. There you go, you're done. So they're saying it's kind of like saying tangent of 60, but you all knew exactly what tangent of 60 was, right? You know exactly what that is. It was square root of 3. Ha ha! No. No, I'm sorry. I was kind of half joking. So we got 60 degrees here. Maybe I'm joking too much. So 60 degrees, your point on the unit circle here, is going to be at 1/2, and then the square root of 3/2. So my tangent is equal to y over x. So that's going to be the square root of 3/2 divided by half. And the 2's cancel and make a square root 3 over 1, which is just the square root 3. Now, back just for a second, is it positive or negative? Well, again, we had this 780 because it went around, and it went around again. So I just like removed that twice and it ended up exactly at 60. So yeah, it is going to be a positive. It is going to be just the square root 3, which is nice. Wow, the next questions are looking pretty crazy. Okay, let me just look ahead. We got 5 questions left. I really want to talk about calculator for a second, though. Let's talk about calculator. It's so important that I truly need to stop and talk about it, okay? So, let's say that I put in sine of 30 degrees. And you get, in your scientific calculator in Desmos, you get 0.5. Well, you can convert this into a fraction very simply, right? No problem. What if you had the sine of 45 degrees and you put that in the calculator and it gives you a decimal of 7071 and some other stuff? This is equal to square root 2 over 2. And you can verify. If you put that into Desmos Scientific and you go back and see what the decimal is, it'll say it's 7071. So that's nice. Therefore, if you see 7071 from your calculator, it means the answer is square root 2 over 2. Let's keep going. Let's say I had sine of 60, and I put that into Desmos Scientific. 866, and of course some more. Well, that is equal to the square root of 3 over 2. So if you ever go to the calculator and see 866, that means it's square root 3 over 2. Let's do some tangents. So if I had tangent of 30, I believe that it's going to be square root of 3 over 3. So let me just verify, if you don't mind for a second. Tangent, 30 degrees, and I'm going to put it back into degree mode. Can't show you all this stuff. Yep, that's correct. My cool Casio 115 gave that answer to me. Again, not allowed on the exams. But Desmos Scientific will give you a 577. If you see a 577, it means square root 3 over 3. Last one right now, tangent of 60. So I'm going to put that in. Tangent 60 says square root 3, again, because I have a super cool calculator. But I need to know what is Desmos Scientific going to give me. And it says 1.73. So if I see 1.73, it means square root 3. Let's go back to my problem. So that was tangent of 780. And I go to the calculator and I put this in, and it gives me a 1.73, a positive 1.73. Guess what the answer is? Exactly. You bypassed all that other work, and you got the answer immediately. This is not wrong. Now, you can't do this with every single angle. You can't memorize every single number. I mean, you could put, I don't know. It just... That's a lot to put in there. It's a lot to figure out. But it's very fast. It's very efficient. And it works a whole lot of the time. If you know these numbers, you're good to go. Okay? It's okay. There's other numbers, but that's good enough for now. I just wanted to do a little side note there because it really makes the homework so much better and faster. I feel limited sometimes because I feel like I have to teach you the book way. Or the My Math Lab method, when really there's so many better ways. When we get to calculus, you're going to just blaze through all this stuff because, I mean, you're going to be familiar with it and you'll have all these other tricks to make it faster for you, okay? All right, back to what we're doing. So cosecant of this guy, give me the answer. Well, first off, again, they want the reference angle first. So reference angle is... 7 pi over 4 is actually down here at 315 degrees. And so they're wanting this little guy, which is going to be 45 degrees. But the formula is 2 pi minus 7 pi over 4 because it's in quadrant 4. And you do the math, and yeah, guess what? It's pi over 4 exactly. Okay, so awesome. 45 degrees. So what is my cosecant of this 7 pi over 4? Well, they're saying it's kind of like saying... cosecant of pi over 4, which is kind of like 1 over the sine of pi over 4, which definitely equals 1 over the square root of 2 over 2. Okay? So what happens here is that this is a little weird. When you take it and flip it, you get 2 over the square root of 2, which is weird. You get 2 over the square root of 2, or 2 times the square root of 2 over 2, and then 2's cancel, and it leaves the square root of 2. Whew. But in your Desmo Scientific, it might have done a 1.414, and so if you ever see that, now you know. There's just one of those key little numbers that you'll be seeing again and again. But this is the answer, but not really. So if you went to the calculator, it's a negative 1.414. The calculator gives you the sign, SIGN sign, automatically, not that sign, the other one, the positive or negative. And so it's actually negative. And if you look back here, isn't this y value a negative y value? And so I got the square root 2, but it's a negative square root of 2. Okay. I feel kind of like I'm losing some of y'all. And I might not. I might be boring some of y'all. But it takes a lot of practice. It also takes a lot of patience, which I guess maybe I'm running out of. I'm trying to get this done. I'm trying to show you all this stuff. But in the end, yeah, I'm human too, okay? I'm human too. I get tired just like everybody else. I get bored. I get like, ugh, do we have to keep doing this? I mean, I'm just like everybody else, okay? All right. They say figure that out. And so there's a few ways we can go about doing this. Honestly, if you type this all into the calculator, it gives you something, but it's a decimal and it's not really helpful. I'm looking here at the answer, and it is wild. So let's talk about this for a bit. I need to find each one of these individually. Notice that it's divided by 4, okay? So, I have like such an easier way to do this, but apparently I'm not allowed to. Anyways, whatever. Yeah, we're just going to do this the MyMathLab way. So, I have divide by 4. So this is going to be a 45-degree line. It's basically going to be a square root 2 over 2 answer. My problem is that I don't know if it's a positive or negative here, okay? So I got to divide by 6 here, and I don't really know exactly what that's going to be, but 5 pi over 6 in particular is on your unit circle. So we'll do that here in a second. I think the big hang up that we're going to have here is, what is 17 pi over 4, right? What is that? So it's way too much. So what I'm going to do is I'm going to reduce it down by subtracting 2 pi. So here we go. So I got 17 divided by 4 minus the 2 is 9/4 pi. Still too much. So 9/4 pi minus the 2 in the calculator. And I got 1/4 pi. So basically like pi over 4, which is 45 degrees, by the way. And so what I'm actually going to say is that, and this is the reference angle, and it's also the coterminal angle, I can just rewrite that strictly as a pi over 4, and I'm not worried about the positive or negative or anything like that because it actually is that value. And the same thing for this one, by the way. That's the same angle, so just go ahead and reduce it down. Okay. I'm not going to do reference angles for these guys because they're actually on unit circle. So on the unit circle, we're looking, and I got pi over 4 right here, and they're saying find the sign. So that's going to be the y value, which is the square root 2 over 2 right there. That's going to be the cosine, which will be the x values, also a square root 2 over 2. So here we go. I'm just going to start doing this. Square root 2 over 2. For my 5 pi over 6, it's way over here. 5 pi over 6. And the cosine is going to be the x value. Again, if you're looking on unit circle, that's going to be a negative square root 3 over 2. Blah, blah, blah for my y value there. So negative square root 3 over 2. Plus sign. Cosine, it's right there. Square root 2 over 2. Positive. And then my sine is the y value. It's right there. It's actually a half. Positive half. So I am using my unit circle directly. Okay? I am using my unit circle exactly. I'm pulling it up and I'm showing you where all these are. No problem. There we go. My goal now is to simplify this thing. And so notice that we have these square roots that are multiplied together. It actually is going to be kind of weird, and I'm going to show you step by step here what this is going to look like. 2 times 2 is 4 in the bottom. There's a 1 right there, I guess. Well, square root times a square root means you can actually mush them together, and so you get 2 and 3 makes a 6. Common denominator. And this is your answer. This is what my math lab's wanting you to do right there, okay? Now, are there particular answers in Desmos Scientific that would equate to this, and you can memorize them? Maybe. I can't. So, yeah, I would say that's a maybe. If you're a professional memorizer, then, yeah, I guess you could just memorize all those. There's a lot more than just this, by the way. There's all kind of variations. Okay. Keep cruising. We're almost done. 3 problems left, and after this one, the others are actually really simple. So we're almost there. Almost there, guys. Push through with me. So sine of 5 pi over 6 minus pi over 3. Wait. That's not what they want. They want more. Plus the sine of 5 pi over 6 plus the sine of pi over 3. This is actually all one statement, all one big number that they want. Okay. So I put this into the calculator again, the numbers, not the pi's, and I got pi over 2 out of that thing. Okay. So what is, all these are on unit circle now. So I'm literally I'm pulling up my unit circle page, and I'm going to look at it. Sine at 90 degrees, my y value at 90 degrees, is equal to a 1. The y value at 5 pi over 6 is a positive 1/2. We just did that one. And then my y value at 60 degrees is square root 3 over 2. Okay, now I've got to actually simplify this thing. First off, common denominator. Notice that right here, we're going to need a 2 over 2. And so I have a 2 plus a 1 plus a square root of 3, all with the common denominator. 2 and 1 combined to make a 3. And there we go. There's my answer. I'm just going to keep cruising because we got to get this thing done. 5, 3, 95. I've got h of g of x. Now, we saw this back a few sections ago where it's composition, all that kind of stuff. I'm going to remind you that this is h of g of x. So g is on the inside. They say that h is equal to cosine x. G is equal to 2x. And they also say that x is equal to 17 pi over 6. And they say, go, figure it out. Okay. So my h is on the outside, and then my g is that 2x. And so then that's basically going to be cosine of 2x. But then it's not just x, because x is equal to 17 pi over 6. And the 2 and the 6 are going to cancel to make that into a 17 pi over 3. And that's where we have to start doing some math magic. So, just like all the other times that we've done so far, how many times have we done this today? I don't know. 17 over 3 minus the 2 is 11 over 3 pi. Still not good enough. Minus the 2 again. And I've got 5 pi over 3, which is on my unit circle, thankfully. So I'm going back, cosine of the 5 pi over 3. Again, unit circle, where is that? It's down here at 300 degrees, essentially. And I'm looking at my x value that's associated with it there. And the x value there is a positive 1/2. And why do I have a negative for my answer? I have a negative 1/2 sitting right in front of me, but that is not correct. It is a positive 1/2. So I don't know what I did. I'm just going to assume that I was wrong, and that is okay. Positive 1/2, we are good to go. That's it. I'm going to do that. Okay, so last one. 53101. I've got the sine of theta. Oh, hold on. Is equal to a negative square root of 3 over 2. And they say theta is equal to blank radians. I don't know how you would do this without a unit circle. And so they also say, hey, just in case, it's got to be between 0 and 2 pi. Yeah, that's fine. So on your unit circle, you're looking around for a y value that looks like it has a negative square root 3 over 2. And guess what? Right here and right here, at 240 and 300, it has this as your y value. Again, blah, 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 negative square root 3 over 2. That's what you're looking for, okay? For both of them. It's like right here and right here, okay? So those are my two answers. And I would love to put that into my math lab and be done. But my math lab is very picky, and it does not like that. It wants radians. Good thing I have my unit circle out because each one of these has a radian associated with it. So this is 4 pi over 3, and this is a 5 pi over 3. And there we finally have both answers, and there is two answers, where that would exist. Done. Done with this section. Thank you very much. Have a great day.